Hi everyone, today I want to talk about the use of BLUPs and BLUs in plant breeding. So BLUPs stand for Best Linear Unbiased Predictions, while BLUs stand for Best Linear Unbiased Estimations. Let's start with BLUs. So BLUs are just means of individuals or families. So if you are comparing individuals or you are evaluating individuals, the mean of each individual or the mean of each family, if you are evaluating families, corrected for outside factors or external factors, is the BLUs, right? So maybe you are doing your experiments in different locations or different seasons or environments. When you get these means and you adjust for those locations, for those environments or seasons, you get BLUs. They are also called adjusting means. One setback about the BLUs is that since they rely on observed data, while you are doing experiment, there is a chance that some few individuals, so if you evaluated very few individuals by maybe a genotype, there's some that are lucky, they fall in a lucky spot and then they perform highly. You may select that they are good performers, but in reality they are just lucky individuals and they performed good because they were just lucky. Now, to compute BLUs, you just get the mean of each individual, the mean of each individual. You subtract them from the population mean. So this gives you a deviation from the population mean. So this deviation from the population mean is corrected by all models' fixed effects. Therefore, if you have those individuals and you take them as fixed effects, what you get is BLUs. So in BLUs, the individuals you are testing or families, they are taken as fixed effect. They are fixed effects. Okay, let's look at BLUPs, the best linear unbiased predictions. They are just statistical estimates that are used to predict the genetic potential of individuals or families. They predict breeding value, therefore they can be used for selection. Two things that you need to know about BLUPs is that number one, in BLUPs we apply a shrinkage. This a shrinkage that shrinks each each mean of each individual towards the mean. Okay, this is to make them unbiased. Okay, unbiased. So you shrink them towards the mean. This is a shrinkage. Secondly, in BLUPs you can factor in pedigree information. Yeah, the kinship, the genetic relationship, the kinship. If you have that information, you fit it there, and then you increase the selection, the accuracy, and the precision of your values, so that it can help you in ensuring that you have good predictions for your selections. So, for you to understand BLUPs, you just get the mean of each individual and you subtract it from the population mean, the way we did in BLUs. However, this value here, this deviation from the population mean, is corrected by the random effects or random effects of the model. So they are random effects, right? And again, after making these random effects, we shrink it by this here. This is just the readability. And this value shrinks the values towards the mean. And these are just the deviation from the mean. And the mean or the average of the deviations is 0. Therefore, the function of this is just pulling those values towards 0. Okay, so irritability values runs from 0 to 1. So if your material has high irritability, it's 1, it means that there's no shrinkage. But if it's about 1, the shrinkage will be very little. But if it's very low, towards 0, it will shrink this value towards 0, therefore shrinking towards the mean. That's about BLUPs. Again, somebody asked me, when you are doing genome-wide association studies and genomic selections, those models, do we fit the phenotype as BLUPs or BLUs? My suggestion is that use BLUs, because those models, they are developed in a way that they treat the phenotypes as random effects, as BLUPs. Okay, if you fit BLUPs into that model, the model again is going to get BLUPs from BLUPs, and you are going to BLUP twice, and you are going to get in that you are going to get some statistical problems, and your result that you get may not be reliable. That's my suggestion, and I hope it's helpful. Kindly like and subscribe.